Hello everyone, I will talk about Cisco router management in this lesson. First we will talk about how to operate our router, then I will talk about Cisco ISR routers and Cisco router interfaces, then I will tell you how we give IP addresses to router interfaces, and finally I will tell you about router auxiliary port. First, let's look at how we operate a router. When we turn on a router, the power on self-test starts first. This test checks the hardware of our device. Does a hardware test such as whether it is running power, does it have RAM, does it have flash? After passing this hardware test, flash memory also searches for Cisco iOS. Cisco iOS flash is also stored in compressed form, decompresses the iOS in flash and installs this iOS on the RAM of the device so that it runs on RAM, after which our router looks for a valid startup config file, and after finding this, it ensures that the device works with the settings in this file. Let's control these processes by putting a router in packet tracer. Let's put one 2911 series router here. Let's click on the router immediately and open it. Let me magnify a little bit so that you can see it easily. Here we show the front and back of our router. Here is the power button of our device. Now the light is green and our device is working. I turn it off from here. You can add various modules to this device according to your needs. You can use your device by adding serial interface module, voice module or switch cards to the example. Here it shows the console connection, here it shows the USB console connection, here there is an AUX port. This AUX port is not available on the switches. When you cannot access the router via WAN, you can connect a modem to this port and access the command line interface of your device over the phone lines. Today, this port is not widely used, but of course it can be used on devices in critical places. There was the CLI security part that we covered on the switch, console connection, line VTY issues are the same with routers, so the console connection, line VTY and SSH commands you make there are also valid here. You can use the commands we use there in the router. Now let's look at the modules you can use, where when you select the card, you can see the card you have selected in the lower corner. When you pull the card and bring it here, you add this card to the device. Here we have a switch card. I am adding 2 switch cards. Now we have 4 plus 4 in total 8 switch ports on our device. We can use 8 hosts on this router. We do not need to buy an extra switch. I have installed a serial interface card here. The router has 3 gigabit ports and 2 USB ports on it. Now let's connect by opening our console. We did not turn on our device. Let's first turn on our device and then connect to the CLI. Right now, the power on self-test takes place first. After the hardware test is done, the iOS and flash is found and copied to RAM and our device is turned on. But real devices are not that fast. This process takes a few minutes. After it is installed on iOS RAM, the startup config file is found and our device is opened. Here I go step by step and ask if you want to make the configuration. I say no because we will make our settings manually. I switch to enable mode by typing enable. With the show version command you can see the version of our device and the hardware on your device. When you type the show version, it shows the model of our device, the version of the iOS installed on it. Currently 1.5.1.4 iOS version is installed. Let's go down. Here it shows where the iOS is installed. Here it shows the hardware on our device. Since we have added 2 switch cards, it shows that we have 8 fast Ethernet ports here. We have 3 gigabit interface ports. These are already on our device. That there are 2 serial interfaces, and here it shows the capacity of our flash. You can see here that this flash compact is 256 megabits. When we go down a little bit, it shows the license status. We have 4 types of licenses on our device as security, UC, data, and 1 IP base. The IP base license already exists in default. If you are going to use the security features of this device, you also need to get the security license. You need to get the UC license in voice. This is how the router first runs, first doing a power on self-test. After the power on self-test, it goes and searches for the iOS and flash. After finding the flash it loads the iOS into RAM, then it finds the startup config file and runs our device. Let's talk about ISR routers on this page. Why do we call it ISR? These routers do not only do the routing operations in our network, but you can also use the switch feature by installing a switch card on the router, the voice feature by inserting a voice card, so Cisco calls these routers ISR. There are various router models. I will talk about these router models in the network architecture section. Now let's look at our network diagram here. There's the central location here, we have the branch here, there's router 1 here, there's router 2 here. We use IP telephony in our head office, we have servers, we have IP phones. Here you need Cisco router if you use Cisco's IP phone exchange, and on the router you need a voice license and voice card. Because this router can multitask at the same time, Cisco defines these devices as integrated service routers. In the figure here you can see the Cisco 4321 router model. We have two empty module boards in this router. You plug these modules according to your needs. If you need more modules, you need to buy a top model. On this page we will talk about Cisco interfaces. At first it was just Ethernet interfaces, so the spelling on the router was like this. Then when Fast Ethernet came out, the command software on it was like this. Then when Gigabit Ethernet came out, the command line on it was like this. You can use the commands of the interfaces that we commonly use in the router as I wrote here. I'm going to show you how to use these commands when we cover IPv4 static route in our next lesson, so let's see you in our next lesson. Hello everyone, in this lesson we will discuss IPv4 static route, IP routing process, IP routing example, and we will finish our lesson by talking about our configuration. The process of moving packets from one network to another using routers is called IP routing. In fact, a routing protocol determines the path that a packet takes throughout the network community, and we can give RIP, IPv2, EIGRP and OSPF as examples of routing protocols. When routers learn all the networks, they use a routed protocol to send user data over the installed structure. Routed protocols are IPv4 and IPv6. In our figure here, a router also shows a summary of the routing logic. This is our Ethernet LAN connection, and here we have a serial WAN connection that works on the HDLC protocol. Here it shows the packet coming to router 1, the packet comes from Ethernet, the router receives the packet, checks the IP header and FCS area in the first stage, extracts the IP packet and sends the packet by selecting the interface where this packet will be output by looking at the route table. We will examine it in more detail on our next page. In our example here we have the subnet 172.16.1.0, 172.16.2.0, and here is 172.16.3.0. 172.16.1.9 here will go to user B of host A. Our default gateway IP here is 172.16.1.1. Let's take a look at what happens when our user here sends the packet. In the first step, router 1 checks the destination MAC and FCS in the incoming packet. If there is no error, it moves to the second step, where router 1 checks the MAC address in the header of the incoming IP packet, that is, checks if this packet has come to it. If this packet has arrived to it and there is no error in the FCS, it goes to the second step, de-encapsulation the packet, removes the packet by discarding the Ethernet header and trailer and moves on to the third step. In the third step, the router compares the packet with the routing table, selects the interface to exit as soon as it sees 172.16.2.0 in the routing table, where the interface serial is 0/0/0. Since it will send the packet from the output interface, whichever protocol that interface uses makes the packet encapsulation again. Since this interface uses the HDLC protocol, it transmits the packet again by encapsulation. In the last step, the router sends this packet that is ready. As for the packet router 3, this router also forwards the packet to the respective host. On this page, let's talk about configuring IP addresses. I will show the commands here when we make the IPv4 static route configuration, but I wrote it here as an example. You can review them from this document. I recommend you to review this document before doing a lab. If you review it, you will understand better when we make lab. Here we also have a static route configuration, which we will already do in our lab. I wrote the example of floating static route here. We do this lab work when we do OSPF. We have two routers here, and we will use 172.16.2.0 as the subnet. We connect our router here with OSPF. We make the static route as a backup here. We will handle this issue in OSPF more clearly. You will understand. Goodbye, to see you in our next lesson. Hello everyone, we will do the IPv4 static route configuration together with you in this lesson. First, let's talk a little bit about our network diagram about the lab. We have one router here, we have a router here, we have a router here, we have switches and users connected to these routers. Here we will use the 172.16.1.0 subnet. Between these two routers we will use the 172.16.4.0 subnet. On the router 2 side we will use the 172.16.2.0 subnet, and on the router 3 side we will use the 172.16.3.0 subnet. We will also use subnet 172.16.5.0 between routers 1 and 3. Normally our routers do not have a serial interface card on them. I showed you how to install a serial interface card on the router in our previous lessons. Now let me show you again. First you turn off your device by pressing the power button from here, then you add the serial interface card from here, then you can turn your device back on. Let's open router 1 first, select this and set it aside so that we can see our CLI window better. Let's start configuring interfaces by opening router 1 here. Let's pull it to the side a little bit to get bigger. I'm writing enable and CONFT. Here we have a gigabit 0/0 interface on our local side. Its IP will be 172.16.1.1, which is what port 1 represents here. Interface Gigabyte Ethernet 0/0. Let's write the IP address 172.16.1.1. Let's write our subnet mask. Routers and interfaces are also turned off by default, so we open our interface with no shutdown command. Let's exit. Now here we have the serial 0/0 interface. Let's configure it. The IP of this interface will be 172.16.4.1. I write the command shortly, insert 0/0/0. I find the IP address from the commands we entered before with the arrow keys on our computer and make it 4.1. Let's open this up as well. Let's log out now. Now let's configure our gigabit 0/1 interface. Our subnet here will be 172.16.5.0 and our IP here will be 5.1. I immediately come upwards with the directional keys from the old commands I entered, and I do this one and press enter. Again, I find the IP address command with the arrow keys and make it 5.1. Let's open this by saying no shutdown. Now we have turned on all our interfaces, but they are still burning red, because the opposite interfaces are closed. These places are still red, and when we configure them in a moment, these places will turn green. We had 3 interfaces here, and we did all 3. Now let's check the IP of our PC. We come to desktop, where we select IP configuration. I have already configured the IP address, and you can configure it as you can do here. In our previous configurations we did not write default gateway, but here we are now, 172.16.1.1 in our gateway IP address. This gateway IP address needs to be an IP from within the subnet you're in. You can't give an IP from a different subnet, so you can't make it like 172.16.2.1. Now let's configure router 2. Let me open this up and make it a little bigger. We also have a serial interface card in this. If you have difficulty opening this lab file, you can make this lab manually yourself. Let's do the serial 0/0/1 first. IP address 172.16.4.2. On the IP of this is 4.2. Let's open this interface as well. As you can see, our interface was opened and it became up. Now let's configure gigabit 0/0, where our subnet is 172.16.2.0 and our IP address is 2.1. Interface gigabit 0/0. I find our IP address with the arrow keys and make it 2.1. Let's open this up as well. We have also made our IP configurations here. We are done here. Our interfaces here have also become up. Here has been up, here has been up, they have all been up. Now let's configure router 3. I write CONFT. Let's configure gigabit 0 to 1 first. I write in GI 0/1. Our subnet is 172.16.5.0 and our IP is 5.2. IP address 172.16.5.2. Since our subnet mask is 24 bits, the default subnet masks of the addresses in Class B were 255.255.0.0. If you remember, the default subnet masks were 255.255.0.0, but since we use the subnets here and we use the subnet mask as 24, the total bit of the first 3 octets is 24. We use the remaining 8 bits for the hosts. In this subnet we can use 8/2 is equal to 256 minus 2, in total 254 hosts. Now let's configure our gigabit 0/0 interface. Actually, I exit here by exiting, but you can write the commands without exiting, but then the tab key does not work. Because the tab key does not work, you can write the commands more easily when you exit by exiting. Interface gigabit 0/0, I find our IP address again in our arrow keys and correct it to 3.1. Let's open this interface. Now that we have configured the IP addresses of all of our interfaces and computers, let's check them out. This place has IPs, they have IPs, and now we have given them all their IPs. Now let's check if we have access to our gateway by sending a ping from our computer here. I write ping 172.16.1.1. We can access our gateway right now. Let's check this out right away. Ping 172.16.2.1. Here you can access your gateway. Now let's open this router and check the route table. Here I come to enable mode by typing end. Let's look at our routes in the route table with the show IP route command. Our router has a 172.16.1.0 subnet, a 172.16.5.0 subnet, a 172.16.4.0 subnet. Because we give an IP to our interfaces on the router, here it shows the 172.16.1.0 subnet as direct connect, and 172.16.1.1 is the IP of gigabit 0/0. Here you see 172.16.1.1/32. This 32-bit here means that this is the IP address, in the same way that our router has 4.0 and 5.0 subnets on it, but this does not know the router 2.0 and 3.0 subnets. If a user here goes to his default gateway to go to 172.16.2.9, when he looks at this gateway route table, he will drop this incoming packet because he does not know where to go to the 2.0 network. In order for the packet to come to this user, we need to write route. We will either write static route or we need to use routing protocols such as OSPF, but since our subject is IP version 4 static route at the moment, we will write a static route and give the user here access here. Now let's first test it and see if it can go. Let's type ping 172.16.2.9 and press enter. We can't access it right now because router 1 doesn't have such a route in the routing table. Now let's come to router 1 and write our route. We write IP route 172.16.2.0 and subnet mask. Let's put a question mark after this. We can write next hop address here. Our next hop address is 172.16.4.2. Here we can specify the next hop address or our exit interface. Let's use our output interface here. Our output interface is serial 0/0/0. We will send the packets that will go to the 172.16.2.0 subnet from this interface. We say enter. Here it gives a warning. If your connection is not point-to-point, you may experience performance problems for this route. There is no problem because our connection is point-to-point. Our route for 2.0 is okay, but we don't know 3.0 either. Let's write a route for 3.0. IP route 172.16.3.0.255.255.255.0. This time let's write our next hop address, not the exit interface. Our next hop address is 172.16.5.2. Let's look at the show IP route table by typing end. When we look at the IP route table, here it means S static. You can look at the explanations of these letters here. When it goes to subnet 172.16.2.0, it exits the serial 0/0/0 interface, and when it goes to subnet 172.16.3.0, it sends the packet to 172.16.5.2. Now we have sent the packets from here to here, but since our routers here do not have any static route, they cannot return to us, so we need to configure static route on these routers as well. Now let's go to router 2, where we write a default route as an example. First, let's check the route table here. Let's write show IP route. The route table only shows the 172.16.2.0 and 4.0 subnets that are directly connected on it. This does not know the router 3.0 and 1.0 subnets, so let's write a default route here and send all traffic except 2.0 and 4.0 to router 1. IP route 0.0.0.0.0.0.0.0 default. This is how we write the route. We write 4 zeros to the IP address and the subnet mask, and then we write the output interface or next hop address. Let's write the IP address of next hop, 172.16.4.1. With this default route that we are writing right now, we will send our users to router 1 by default wherever they want to go. In fact, we write these default routes in the direction of the internet in our internet exit routers. When the router here will connect to the internet, we show our output interface as the default route to the users coming from here. But I made this example to show you how the default route is written here. Now let's do the third router. Our router here knows the 3.0 and 5.0 subnets. He doesn't know the 1.0, 4.0, and 2.0 subnets. He doesn't have a job with the 4.0 subnet anyway, only the 2.0 subnet has hosts. Let's open our router and write our command, iproute 172.16.1.0, subnet mask. Our next hop address is 172.16.5.1. I've put 2 dots here, so I'll correct it. Let's do it in 2.0, and to go to 2.0 it will go through router 1 again. Now let's do our tests by opening PC1. Let's see if we can access PC2 and PC3 from PC1. As you can see, when we type ping 172.16.2.9, we can now access PC2. Now let's look at 3.9. First it is timeout because an ARP package goes back and forth, but then, as you can see, we can access it. Now let's use the traceroute command in Windows. This command shows the way we went. I write traceroute 172.16.2.9. I wrote 2 dots here again, so we had a problem. Our user here first goes to 172.16.1.1, where he looks at the gateway route table and sends it directly here from the output interface for the 2.0 network, and the router here transmits the user. This is how we can configure static routes on all our devices. So goodbye to see you in our next lesson on our static route configuration. Hello everyone, in this lesson I will tell you how to do IP version for routing in the local area network. First, we'll look at the example of VLAN routing with an 802.1q trunk on a router, and then I'll tell you how we do Ether channel on router on a stick, SVI, root port, and layer 3. In the figure here, we show the layer 3 switch use case. I told you about the layer 3 switches before, but we did not go into too much detail. Now let me tell you a little more in detail here. If I'm using the word switch, you can tell that there are devices that work on layer 2, and if I say layer 3 switch in particular, you can tell that this switch is a layer 3 switch. The difference between layer 3 and layer 2 switches is that layer 3 switches also support IP routing features, which means that routers on switches can perform IP routing operations. Here we have 2 layer 3 switches in our center, and the router in the branch is made of router on a stick. Now I will tell you about router on a stick. When we discussed data forwarding between VLANs before, we said that we need a router to be able to do data forwarding between VLANs. In small branches, there may not be layer 3 switches, we will have routers and switches there. Considering that we have VLANs such as VLAN 10, VLAN 20 and VLAN 30 on these switches, it will not be practical to connect a cable to the router for each VLAN, so we connect a single cable and create sub-interfaces under this router interface and configure router on a stick. We have one interface here, but we create a sub-interface by saying .10 under this interface, we create another sub-interface by saying .20, we connect our router to the switch in this way with a single cable, we make the port of the switch connected to the router as a trunk and make all the VLANs on our switch reach the router through a single port. Now let's look at the other method. Let's look at configuring VLAN routing with SVI on layer 3 switch. We have a layer 3 switch here, they put a router symbol here, but it's actually a layer 3 switch. And because layer 3 switch has a routing feature, they put a router icon here. There are VLAN 10 and VLAN 20 on the layer 3 switch here. Our users in VLAN 10 and VLAN 20 use layer 3 switch as the gateway. The IP address of interface VLAN 20 here is 10.1.20.1, and the IP address of interface VLAN 10 is 10.1.10.1. The users here go to the IP address here as the gateway, and the layer 3 switch routes these users by looking at the route table. VLAN 30 is also used between the router and the switch. The port of the router is given an IP of 10.1.30.2, here the interface VLAN 30 is given an IP because the port of the switch is not given an IP, so our traffic here is provided in layer 2, and when our users here go to the router, they reach the router as layer 2 from the gigabit 0/1 port of this switch. This is how we can do SVI configuration. You will understand better when we make labs a little later. Now let's look at configuring VLAN with root port in layer 3 switch. The only difference from SVI is that we do not use VLAN between this router and layer 3 switch. We make that port a root port by saying no switch port of the switch here. When we make a root port, we make the traffic between the router and the switch on layer 3 by giving an IP address to our interface and router. Then the traffic from the users comes to the switch from layer 2, where the packet is sent from layer 3 if they need to go to the router. Let's not forget to turn it on an IP routing feature on our switches. IP routing default is turned off in layer 3 switches. You need to turn it on with IP routing command. If you do not turn it on, IP routing will not work on the switch. We've covered the layer 2 Ether channel before, so let me show you the Ether channel configuration on layer 3 switches. When we look at the example here, we have distribution switches, we have access switches, and we have core switches, and we'll revisit this design topic in the network architecture section. Since we have dual connections between our core and distribution switches here, and since these switches have layer 3 switches, we can also configure Ether channel instead of root port between these switches. Here we give the IP address to the port channel, we say no switch port and no IP address in our ports. We indicate that this port will work as root port and channel group 12 or 1 as you want. After specifying our group, you give an IP address under port channel, you give an IP address here and you give an IP address here and you make the traffic go back and forth in layer 3. Now let's start with our labs and do them all one by one. Hello everyone, we will make the router on a stick configuration in this lesson. First let's take a look at our network diagram and see what it is. In our topology, we have one switch, one router. Here we have two users in VLAN 10, and we have two users in VLAN 20. I have already entered the IPs and gateway IPs of the computers, and if you have problems opening the lab, you can do it manually yourself. There is no configuration on the switch, there is no configuration on the router. Now we will create VLAN 10 and VLAN 20 on this switch. We will make our port connected to the router a trunk port. We will create two sub-interfaces on the router side. We will create gigabit 0/0.10 for VLAN 10 and gigabit 0/0.20 sub-interfaces for VLAN 20. The gateway of our users here is 10.1.10.1, that is, the IP address of the sub-interface that we will create in the router. Users here will come to the router and VLAN to VLAN routing will be provided through the router. First, let's start with the switch. I write VLAN 10. When I type VLAN 20 without exiting here, VLAN 20 is created, but you need to type the command exactly, where the tab key does not work. Let's call it exit. Let's do both ports at the same time using the interface range command. We say switch port mode access. I write switch port access VLAN 10. I write the commands briefly. Let's go back to the old commands with the arrow keys, type 3 and 4. When we say 3 and 4, we say third and fourth. We went under the port, I find the switch port mode access command with the arrow keys, then I type switch port access VLAN 20 into it. Interface gigabit 0/1 I will also make a trunk, that is, our port connected to the router is gigabit 0/1. Switch port mode trunk. From now on, all VLANs on the switch will be tagged and sent to router 1 from this port. Let's check our settings with show run. Fast Ethernet 1 and 2 on VLAN 10. Fast Ethernet 3 and 4 at VLAN 20. The trunk and the mode of our gigabit 0/1 interface. Now let's configure our router. First I go under this interface by typing interface gigabit Ethernet 0/0 and I open this port saying no shutdown, then I write no IP address and specify that I will not give an IP address. After logging out, I find it again from the commands I typed and put a period at the end. After this point I specify the sub-interface number, where the number may start as 1, 2, 3, 4, but since we use VLAN 10, I write 10 here to make it easier to remember. You do not have to write 10 here, but if you type 10, it will be easier for you to understand that it is VLAN 10. In subinterface, we determine the VLAN we will use with the encapsulation.1q command. I write 10 here. The VLAN ID we write here is important, but a number we write here does not matter. We can write any number. IP address 10.1.1.1.255.255.255.0. I find the commands I typed and create subinterface 20 from the shortcut. In this, I say encapsulation.1q20, I say I will use VLAN 20. Again, I find the IP address with the arrow keys and make it 20.1. Now let's check our settings by saying end. When we look at gigabit 0/0 here, we see that there is no IP address and it is open. Here you can see the subinterface that we have created, gigabit 0/0.10, this is our subinterface number. Here we have a VLAN ID at 10, encapsulation.1q, likewise here we have a subinterface 20, here we are done. Now let's check if there is access to the router from the PC. I write ping 10.1.1.1. Now that we have access to the gateway, let's look at 20.1 and see if it does. 20.1 is also okay. So let's see if we can access the user in VLAN 20 here. Let's write 20.3. As you can see, VLAN to VLAN routing is now provided. At the moment we have not written any route, because here in the route table, the users in the 10.1.10.0 subnet go to router 1 when they go to the users in the 10.1.20.0 subnet. When router 1 checks the routing table, it sees that this subnet is connected directly on it and sends the packets from the relevant interface. By configuring router on a stick, we have ensured that the data forwarding process between VLANs takes place. That's all we have configured. Now the VLAN to VLAN routing process has been carried out. If you don't want users here to access it, or if you don't want some users to be accessed, then you need to write access control list on this router, which I will explain in our next lessons. Goodbye to see you in our next lesson. Hello everyone, in this lesson we will configure VLAN routing with SVI on layer 3 switch with you. Now let's take a look at our lab topology. We have VLAN 10 in the turquoise area, we have VLAN 20 in the orange area, we have a router in the yellow area, and this is VLAN 30. We have a layer 3 switch here. Our users will use the layer 3 switch here as the gateway. I've done the IP and VLAN configurations on the computers here and on the layer 3 switch, and I'm not doing them again because you've already learned about these configurations. Fast Ethernet 1 and 2 on the switch are in VLAN 10, Fast Ethernet 3 and 4 are in VLAN 20, Gigabit 0/1 is in access mode and VLAN 30. Now we will create interface VLAN 10, 20 and 30 on our layer 3 switch and give them IP addresses. Our VLANs are working now, but there is no routing between VLANs. Let's open PC0 and test them. Ping 10.1.1.3. Now that you can get here to here, let's ping the gateway IP. The gateway IP is 10.1 but it cannot access this IP address because we have not configured it on the switch at the moment. Now let's see if it can access VLAN 20, let's go to 20.2. So let's ping here and here. There is no access there at the moment because we have not made the VLAN routing configuration. Now let's turn on our layer 3 switch and check our configuration. Let me show you the settings I made by typing show run. Fast Ethernet 1, 2 at VLAN 10, 3 and 4 at VLAN 20, Gigabit 0/1 at VLAN 30. We cannot give IP addresses to interfaces on layer 3 switch, but if we make that interface a root port with no switch port command, then we can give an IP address, but we will give IP to VLAN interfaces here. I am writing interface VLAN 10. The IP address is 10.1.1.1. Users in VLAN 10 will use this IP address as their gateway address. Interface VLAN 30 I write. I make the IP address 30.1. Now let's check by typing show run. You can see the IP addresses of VLAN 10, VLAN 20 and VLAN 30 here. Now when we type show IP route, no route will appear because we have not turned on IP routing on the switch. No route will appear because we have not turned it on. No route appears at the moment. Let's write CONFT. Let's turn on the IP routing feature by entering the IP routing command here. Now let's say end and write show IP route. It does not show the 10.1.30.0 subnet because the interface on the router side is closed, so this port is not yet active. Its China does not show it here. A little later, when we open the router's interface, we will be able to see the IP address of the VLAN 30 here. Our layer 3 switch has 10.1.10.0 subnet, 20.0 subnet and 30.0 subnet on it. Now the users here will come to their gateway when they will go to the users here, and their gateway will do the routing by looking at the routing table. Now let's do a try. Let's try to access PC3 from PC0. I write ping 10.1.20.2. As you can see, our traffic between VLANs is active right now. Now let's set up our router. Let's say enable. Let's switch to global config mode by typing conft interface gigabit 0/0 IP address 10.1.30.2. Let's write our subnet mask and open our interface. Our layer 3 switch provided the traffic between VLANs in our network. Now let's imagine that our users in this VLAN will go to the internet. When they go to the internet, they first come to their gateway. In this gateway it forwards the incoming requests to the router here. It sends the requests that come from this router to the internet, but now our router does not know the subnets here, so it cannot go back here. Let's check with show IP route. At the moment, only our router knows the 10.1.30.0 subnet because it only has this network on it. He doesn't know the networks here, so let's teach the networks here by writing a static route. Let's write IP route. Instead of typing 2 lines of command for the 10.1.10.0 network and the 10.1.20.0 network, I will write 10.0.0.0 and send it to all addresses in the 10.0.0.0 network to the gigabit 0/1 to 10.1.30.1 next hop. We write default mask 255.0.0.0. To go to all the networks in the 10.0.0.0 network, I write 10.1.30.1 as the next hop address. Now let's write default route on the switch. I write conft IP route 0.0.0.0. Let's write 0.0.0.0 in our subnet mask. Let's send it to our router as next hop, 10.1.30.2. When our users here want to go to the 10.1.20.0 network, they come to their gateway and the layer 3 switch routes the packets here by looking at the route table. But let's say they want to go to the internet, then they look at the layer 3 routing table and send the packages to the router 1. And the router 1 sends this request to the internet. To do the test, let's create a loopback interface on the router. These interfaces are virtual interfaces that run on the router. Let's write interface loopback 0. Let's make the IP address of this 8.8.8.8 as an example, as if it were Google's IP address. Since this address directly represents the host, I write 4255 in the subnet mask of this. I'm exiting. According to our scenario, I created a virtual IP address as if our router were connected to the internet here and there is Google server here. Let's ping 8.8 from our user here. I write ping 8.8.8.8. We pretend to ping Google. As you can see now, our users here have access to the internet. Our user first comes to his gateway here and looks at the route table on the switch here and sends it to router 1, looking at the route table on router 1 and sending the user to the internet as if there is internet here. But now of course there is no such scenario. I created a virtual interface here and I gave the 8.8 IP address to the virtual interface I created here. And the virtual interface we created here returned to the user here. Here we made the default route. And here we created a static route towards the 10.0.0.0 network and provided the return of traffic. Since we use SVI in our traffic between the router here and the layer 3 switch, the traffic coming here goes to layer 2, but in the lab that we will do a little later, we will not use VLAN between this router and this switch. We will make the port of the switch here with the no switch port command, then the traffic between the switch and the router will be made in layer 3. Goodbye to see you in our next lesson. Hello everyone, in this lesson we will configure VLAN routing using route port on layer 3 switch. Now let's take a look at our topology. We have VLAN 10 and VLAN 20 in our topology. I have already configured the IPs of the computers here. I have also created the VLANs on this switch. Fast Ethernet 1 and 2 are on VLAN 10, Fast Ethernet 3 and 4 are on VLAN 20. I will give the gigabit 0/0 port of our switch the IP of 10.1.30.1 to this port of the switch by stating that it is no longer a switch port with the no switch port command, and now our traffic between the router and the switch will go back and forth at layer 3. First, let's connect to our switch and activate IP routing. I have activated IP routing using the IP routing command. Now let's write end and check with show IP route. When I type show IP route, nothing appears, because I haven't configured the IP addresses of the interfaces yet. Let's do them now. Interface VLAN 10, IP address 10.1.10.255.255.255.0. Now I found VLAN 10 from the old commands I entered with the arrow keys and changed it to VLAN 20. Let's find the IP address immediately and make it 20.1. I write end and look again with the show IP route command. Now that 10.1.10.0 subnets and 20.0 subnets are active, our traffic between VLAN 10 and VLAN 20 is now active. Let's do our tests right away. Let's ping PC0 user here to PC3 user. First let's check if there is access to the gateway. I write ping 10.1.10.1. He has access to the gateway. Let's try 20.2 now. The switch here first sends an ARP packet and learns the MAC address of 10.1.20.2. After learning the MAC address, it transmits the packet to the PC3 by enclosing the Ethernet frame in layer 2. Our VLAN routing configuration on the layer 3 switch is okay, but we need to go out on the internet through this router, so we will make our gigabit 01 interface here a root port. Interface gigabit 0/1. I write no switch port. When I enter this command, this port becomes root port. When this port is root port, you can now give an IP address here. IP address 10.1.30.125.255.255.0. We have given our IP address. Now let's write the default route to exit and go to the internet. IP route 0.0.0.0, subnet mask, 0.0.0.0, next hop 10.1.30.2, we send to router 1. I say end, it is not active because the router's interface is turned off at the moment. Now let's configure the router side. Interface gigabit 0/0. IP address 10.1.30.2. It's 130, let's fix it right away. Let's write our subnet mask and open our interface. Now let's check by typing show IP route. Since only 10.1.30.0 subnet is directly connected on our router at the moment, we can see this subnet here, but we do not know the other networks. Let's write static route within these networks. IP route 10.0.0.0. Let's ensure that it covers all networks, 255.0.0.0. With this route, we will route to all subnets in the 10.0.0.0 network. I write 10.1.31 as the next hop address. Now when we do the test, it needs access to the user here. Now that our ping has been successful, let's go to 20.2. As you can see, now your router has access to the user here, and your users here have access to the router. We also have a default route on our layer 3 switch. Let's create a virtual loopback interface in the router to test it. Interface loopback, I write 0. Let's make the IP address 88. Now I'm testing from users. I open the PC1 user here. As you can see, the ping is successful. Now let's look at which ways we go by making a tracert. First it came to 10.1.10.1, from here it went to 8.8, 8.8 came directly here because it was on the router. This is how we configure VLAN routing with the root port on the layer 3 switch. First of all, we have provided the VLAN traffic of our users by doing our inter-VLAN routing on the layer 3 switch, then we have created a default route and sent the user's traffic to the internet direction to router 1. This is all we will tell you in this lesson. Goodbye to see you in the next lesson. Hello everyone, we will make the layer 3 Ether channel configuration together with you in this lesson. Now let's first look at our network diagram. In the green area we have VLAN 2, here we will use the 10.1.2.0 subnet. In the yellow area we have the VLAN 3, here we will use the 10.1.3.0 subnet. We have two layer 3 switches, and between these two switches we will use the 10.1.12.0 subnet. Between these two switches we will create the interface port channel 12 and make Ether channel between these switches at layer 3. I already gave the IP addresses on our PCs. I gave the IP address of the interface VLAN 3 on this switch, and I assigned the fast Ethernet 1 port here to the VLAN 3. Because you know these configurations, I have done them before, I have done the same way this side. Now we will only do the layer 3 Ether channel configuration. Let's start configuring our first switch by opening the CLI. I switch to global config mode by typing CONFT. Let's configure gigabit 0/1 and gigabit 0/2 here. Let's configure it at once with the interface range command. I write no switch port. Channel group 12 mode I'm doing desirable. Here we will use port aggregation protocol. When we do channel group mode 12 here, interface port channel 12 is auto-generated. If you want, we can look at it with show run. Here interface port channel 12 is created. Now let's give it an IP address. Interface port channel 12, IP address 10.1.12.1. Let's write our subnet mask and open our interface. Let's exit. Now let's make the settings of our second switch. Here we will make the same settings. Interface range gigabit 0/1 and 2. I say no switch port, I choose the channel group. Let's get auto in our channel group 12 mode. We made the other side desirable and we made auto here. Now let's look at our settings by logging out. Now that interface port channel 12 has been automatically created, let's give it an IP address right away. Interface port channel 12, IP address 10.1.12.2. Let's write our subnet mask. A little while ago, a port of our switch was blocked because of the spanning tree, but now that we have an Ether channel configuration, all of our ports have become green. Let's check with the show Ether channel summary command. We see that our group is 12 and it says RU here, which is our layer 3, it shows that U is in use. Here we can see that our protocol is port aggregation protocol and our ports. Now let's look at it with show IP route. Our switch has 10.1.3.0 subnets on it, it is 10.1.12.0 subnets, but we don't know the 10.1.2.0 subnet here. We can't access it because we don't know this subnet right now, so we can't access VLAN 2 from VLAN 3, we need to write a route to access it. To go to 10.1.2.0 subnet, we send IP route 10.1.2.0.255.255.255.0 and next hop address via port channel by typing 10.1.12.1. Let's check the route table by logging out. When we write show IP route, we can now see it in the route table of 10.1.2.0 network. The two switches are now layer 3 Ether channels, where packets will be transmitted to layer 3. Let's check the settings on our first switch with the show Ether channel summary command. We can see here that the Ether channel is active and works in layer 3. Here, too, let's check the routing table. I misspelled this place needs to be 10.1.2.0, let's check this now. I misspelled the IP address of interface VLAN2, let's fix it right away. Our IP address should be 10.1.2.1. I enter interface VLAN2. To remove a command we need to write no at the beginning of the command. Now we copy and paste the old address here and remove the command. Now I'm pasting the old address back in here and editing it. I'm making this 2.1. Let's check our settings by saying end. Now we can see 10.1.2.0 subnet here, 10.1.12.0 subnet here. At the moment we do not know the 10.1.3.0 subnet. Let's write a route for our user here to go to the 3.0 subnet. I write IP route 10.1.3.0.255.255.255.0, 10.1.12.2. Now let's check our settings again. Now that we have completed our Ether channel configuration, let's do our testing. Let's open PC 0 and first ping the gateway address. I write ping 10.1.2.1. He has access to his gateway. Now let's try to access the 3.2 user here. Now, our connection between these two switches is both redundant and our traffic is gone at layer 3. This is how we do the Ether channel configuration, so goodbye to see you in our next. Hello everyone, in this lesson I will show you some of the commands that we use to troubleshoot the error in IPv4 routing. We will make error detection using the ping command, then I will show you the use of extended ping, the traceroute command and the extended traceroute command. And finally we will finish our lesson by looking at troubleshooting with Telnet and SSH. First of all, let's take a look at how we detect errors using the ping command. We have already used the ping and traceroute commands many times before, now we have a reminder here. The figure here shows a simple error troubleshooting example. The user Sally here cannot access the Windows server here. We will try to solve this problem by pinging. First we open a command line on the PC. When we open the command line we ping to 127.0.0.1. This IP address is the system diagnostic or loopback address. If we can ping this address, it means that your TCP IP stack is working. If you do not ping this IP address, there is a problem with the TCP IP stack on your computer and you will need to reinstall TCP IP on the host. Our next step is to ping the PC's own IP address. If the PC can ping its own IP address, there is no problem with the networking interface card and TCP IP protocol. The third step is to ping our gateway, and if we have access to it, we finally ping the server. Ping stands for Packet Internet Groper. Ping uses ICMP echo request and reply messages to test whether the TCP IP stack has started on a network. Traceroute, on the other hand, displays us the list of routers in the path to a destination network using TTL timeouts and ICMP error messages. You can use this command as traceroute in Windows. The ARP-a command is also a command that works in Windows. This command does not work on Cisco devices. This command is the command we use to find MAC address mappings from the IP address. You can use the show IP ARP command on routers and switches. We also use the IP protocol configuration/all command to see the IP configuration on our computer. A little later we open Packet Tracer and do all of this. The figure here also shows an example of the use of extended ping. In this example we will examine how to ping user B from router 1. When we ping on the command line and pressing enter, it shows us that the protocol type is IP in default. Then we write the destination address and continue by saying enter, where we indicate how many times to do it again. Then we proceed by pressing enter. Here we can also write the source interface IP address. If we want, we can send pings from the IP address of the interface here, not from the interface here. This is one of the features that we use to do testing, and I'll show it on the packet tracer a little later, and I'll show the traceroute command in a moment. There is an output of the extended traceroute example here, and we will do this in a moment. Here is an example of Telnet and SSH, in which PC1 can connect to router 1 via Telnet and SSH, but not Telnet and SSH to router 2 and router 3. Here the PC1 can access the router 1, the router 1 can access the router 2, and the router 2 can telnet to the router 3 because they are all directly connected to each other. But since there is no routing configuration here, you can access here, but you cannot access here, because you know the network here, but you cannot access here because you do not know the network here. Now let's open Packet Tracer and take a look at them there. Let's first check our IP configuration. Turn on PC1. When you type this command, it will give you information about the IP configuration in Windows. Here you can see that the IP address is 10.1.10.3, where it shows the physical MAC address and subnet mask. Default gateway IP, DNS server and DHCP server IP addresses are also not. Let's also use the command ARP-A. I write the ARP-A. Since there is no traffic at the moment, it does not show anything. Here we will see the ARP information when we generate traffic. Now let's ping from PC1 to router 1. I write ping 10.1.32. Now let's look again. As you can see, the user here has learned the MAC address from the IP address of the gateway because he went to his gateway. He did not know the MAC address of the port where this IP address is located before. To find out, he sends an ARP request packet to the network asking for the MAC address of the user who uses the IP address 10.1.10.1. When this user receives this ARP message, he returns this message and transmits the MAC address. This is the case with the use of ARP-A. Now let's check if the TCP IP stack is working. I write ping 127.0.0.1. Now that the ping is successful, our TCP IP stack is running, so let's ping our own IP. I write ping 10.1.10.3. If we can successfully ping our own IP address, we can understand that there is no problem with our network interface card. Since we can already access the router here, we can also access our own gateway. Now let's examine the extended ping and traceroute command on router 1. I switch to enable mode because our show commands run in enable mode. I write ping 10.1.10.3. Our ping was successful. Now let's look at extended ping. I type ping and press enter. It asks for the type of protocol. The default is also IP. I continue. Target IP 10.1.10.3. Repeat count default 5 at the rest. Datagram you get 100. Timeout 2 seconds. Extended commands. Yes, I say. It asks for the source address. Normally when we ping it will log out of this interface and come here. But we want to use the interface IP address here. The IP address of our interface here is 192.0.22. I continue by saying enter. As you can see, our ping is successful. Thanks to this feature, we can detect errors using a different interface IP address on the router. Now let's use the traceroute command. I write traceroute 10.1.10.3. First of all, it comes to 30.1, from here it reaches the PC1. Let's look at the extended version of it. I type traceroute and press enter. The protocol type is IP, the target address is 10.1.10.3. Our source address is 192.0.22. I continue by saying enter. Here it first goes to 10.1.31, and from here it goes to the user. Here we have traceroute from this interface, not from this interface. You can use these commands for troubleshooting and troubleshooting. These commands are one of the two most useful commands that will work for you: ping, traceroute, ARP-A and show IP ARP. Let's check the ARP table here. I write show IP ARP. With this command, we can see the MAC addresses of all the IPs we generate traffic to here. That's all we will tell you in this lesson. Goodbye to see you in our next lesson.